these two indices with these two indices, because this is antisymmetric. That's what the square brackets is. So you can define an equivalent quantity. You can trade this for something with just one index, one tangent space index, and then you can define the following combinations: omega a mu which is omega mu a plus, so e mu a and a mu tilde. So you can define the sum and difference of these two quantities, omega and e, where L is the cosmological, is the radius of ADS, so 1 over L square is proportional to the lambda, minus 1 over L square is proportional to lambda ADS, the cosmological constant. So it's L is the so-called radius of ADS. At the moment, you just can think of it as a length parameter that is there. So you can make this combinations of omega and E, and these two now can be viewed as, so I'll just stop in a minute. So these two can be viewed. So the reason to use the notation A is suggestive, is to remind you, to make you make you think of gauge fields, and indeed the A and the A tilde are transformed under the local Lorentz transformations, under these kind of local Lorentz transformations. As SL2R, which is the same as SO2 comma 1. So remember, in our case, we are in D equal to 2. So so the tangent space is, we are in ADS3, so the tangent space is SO2 comma 1. So these transform as SL2R valued gauge fields. So like ordinary non-abelian gauge fields do transform, if you, I hope all of you have seen how non-abelian gauge transformations act on gauge fields. So so this A and A tilde behave like gauge fields, and next time I'll write down how this formulation enables you to write down the Einstein gravity in 3 dimensions in the presence of a cosmological constant in a very simple way, and how this generalizes very naturally to the higher spin gauge fields. So let me stop there.
Questions? I have a question. Do we know in Vasilev's theories how to add like multiplets of matters consistently?
Yes, so that's a very good question. I didn't go into that part, but indeed Vasiliev showed that you could couple matter to his equations, but it was very constrained. So at least the simplest form of coupling that has been studied is that in which, in the say the purely bosonic Vasiliev theory, you can couple a scalar field to ordinary spin 0 scalar field, in addition to all the higher spin gauge fields, but it has to have a very specific mass, and the couplings are very fixed. I mean, the whole interaction is fixed completely. So you can't add any arbitrary potential or anything like that. There's a very definite coupling to the additional fields. So it's very rigid. So in general, in the supersymmetric versions of the Vasiliev theory, you can supersymmetrize them as well, so that you have higher spin fields of half-integer spin. In those, you can also couple spin half matter, but again with very specific mass, which is determined by the gauge symmetry algebra, and interactions also. So it's a very rigid this thing. So you can't, unlike in say Einstein gravity, where you could have a scalar field and couple it basically by using any diffeomorphism invariant coupling, and you could have arbitrary potentials and so on. In the Vasiliev theory, it's much more, the whole structure is much more rigid. The mass is fixed and interactions are fixed. So that's the simplest one that is understood. But in one of the things in this embedding of Vasiliev theory into string theory, what it seems to sort of indicate is that there is probably a more general way in which you could couple many more fields, an infinite tower of additional matter fields to the Vasiliev theory. But that sort of coupling, I think, is much less explored. And in fact, I think that would be the sort of goal in trying to understand this sort of aspect about how this symmetries constrain string theory, that somehow the structure of all the massive states in string theory must be also constrained by this Vasiliev symmetry that is there in a Higgs form. But yeah, that is much more than what Vasiliev himself has studied. So presumably, if you want to couple finite amount of matter, there is the Vasiliev kind of coupling. But there is presumably a way in which you can couple an infinite number of other matter multiplets as well. But and that's presumably what string theory does.
Okay, so let's take a break and come back at 4 o'clock.